welcome back to a brand new video. So today we are going to be checking out this problem that I actually came up with in my head. If we assume that the sum S of n is equal to 1 plus 2 plus 3 up to n, so we're just taking the sum of all the positive integers, and we assume it terminates at some even integer, then what can we say about the summation? i.e., does it converge to a positive integer? Well, it's going to be positive, sorry, a even or odd integer. So let's go ahead and start investigating this thing. So the first thing we can do is we know it terminates at some even integer. So n is nothing but equal to some 2k plus 1. So, sorry, 2k, even integer. Plus 1 would be an odd integer. So we can allow s of k to be nothing but 1 plus 2 plus 3 plus ... plus 2k. Okay? And that is just the same sequence because we're just stating that n is equal to 2k. That's all we are changing. But what can we do here? Well, in a theorem, what we find is, well, this number, its predecessor, is nothing but 2k minus 1. So s of k is nothing but equal to 1 plus 2 plus 3 plus ... plus 2k minus 1, some odd number, plus 2k. Okay? You might be wondering, okay, that means we can join the 2k's together, but let's settle down here. Let's try and think of this a bit differently. Let's split the odd parts away from the even parts, such that we get this. Okay? And that is quite an interesting solution. You might be wondering why. Well, in theorem, we are able to take a factor of 2 out of this one because they're all even. Alright? So, that would mean that we get 1 plus 3 plus ... plus 2k of minus 1 plus 2 of 1 plus 2 plus 3 plus ... And in theorem, it is going to converge to that 2k again because it's nothing but the same sequence. But really, we've taken a factor out of 2, so we just take it up to k. It's not actually going to converge to the same sequence. It's going to converge to some integer k. And in theorem, does this mean it is an even summation or a odd summation? Well, you can't really tell just yet. Let's go ahead and do a few more manipulations here. So we have this terminating at k. Okay? Now if we think about this, this is nothing but the sum. This is nothing but the sum from k running to 1 to 2, let's allow it to be p actually, from p equaling 1 to k of sum of positive minus 1. Okay? And of course, we get this being 2 multiplied by the summation from p is equal to 1 to k of nothing but p. Okay? Well, we can say that in light of us knowing that this is nothing but some integer, then this part is going to converge to that even part. And that's just basically this note that we've had here. We know that we've split the even parts. This just goes to prove it. And this proves here that it's nothing but an odd number. It's going to converge to an odd number. So what's an odd number plus an even number? Well, an odd number plus an even number usually is, for example, an odd number, isn't it? But two even numbers is an even number. But you nearly always get an odd number when you go even plus odd. So what's this telling us? What is this telling us? Is this telling us that this summation is going to converge to some odd number? Well, first things first, we actually can combine these two summations. If we bring the 2 back in front of the sum, then we get nothing but p is equal to 1 of k to 2p minus 1 plus the summation from p is equal to 1 to k of 2p, where this again is just even and this is odd. Okay, so we combine the two sums and we get nothing but the summation from p is equal to 1 to k of 4p minus 1, and that is our summation for some k integer. But recall that n is equal to 2k, so really what would it look like as our sum here? Well, this is equivalent to that idea. So for example, if we took k to equal 5, then we'd just get, okay, the first one is going to be what? Is going to be 3. The next one is going to be 7. And you might be wondering, okay, why is this? Well, if we look back at the previous thing, what it's done is it's added some of these numbers up. They are the same. We can legitimately just go 1 plus 2 plus 3 plus 4. Okay? So it's just another way of writing the summation. It's the same value, but it's all added together within this summation, is what I'm trying to say. So 4p minus 1, and that is odd numbers summing together. So what can we say? Well, we can say that all the positive integers up to an even number k, or n is equal to 2k, sorry, in a technicality, is going to converge to an odd integer. Okay? So that is a proof that this summation indeed sums to give an odd integer if and only if the last integer in that summation is an even integer. In the next video, we will continue on this forum, on this OneNote page as well. We will look at what happens if our last number is an odd number? And namely, that will be n is equal to 2k plus 1. So guys, if you guys enjoyed this math video, remember to leave a like on this video if you enjoyed it, subscribe for more, and I'll see you guys in the next one.